Hello, everybody. Here we are talking about the things that we love best, which is to say making great game experiences. My name's on the slide, so is my colleague from Epic Games. Won't say it to you, but you can see we're in batch mode. We're all about efficiency, so you get two of us at once. Don't be confused by the naming. Now, what can we say about games? We know that they are visceral, graphical experiences. Quality matters, performance matters, and this space is incredible. I'm always impressed by generation on generation, not just how much the hardware improves, but the way in which the humans utilize it, leverage it to create experiences that have not been seen before or otherwise amaze and delight our users. And so you can dive into the tech. We can talk about the way in which the high quality that's being rendered onto screens, and in the mobile space where I spend a lot of my time, the screen resolutions are incredible. You know, they go way beyond what many of you might have in your flat panel TVs at home. But it comes with constraints, and you have to be inventive around those. I think it's fair to say that everyone that we're speaking to today has a mobile phone, has a smartphone, and you use it for so many things during the course of your day. You want to carry it with you for your email, for your socials, and maybe for a bit of gaming. And so we have to play fair, we have to use the resources wisely so that you find that you're getting the best out of your smartphones. And that's a challenge for many a mobile game developer, and something that I feel that people at Arm, where I work, have something to offer back to help you get the results that you're looking for. So, everything comes with a cost. We know this, whether you're on a PC, whether you're on a mobile handset, whether you're working on a console-based experience. You have to invest the GPU time, you're spending the power, and you have to make sure that you're presenting at the right quality bar. Everything matters because speak all you like about the tech, it's about the user experience that you render, the expressions that people come away with after they play your game. So how do we work with this? How do we work with our finite resources in order to deliver the results that we're hoping for, that we want to offer back? There are many techniques, some of which are well established in game development law, others which are more novel. So understand exactly how to arrange your data, minimize the amount of traffic, utilize your CPU and GPU as best you can in the work that they do. Super resolution has a great history to it. And when it comes down to it, it's a cheat, like so many of the things that we do in graphics. We start with a low resolution image, complete that, and then via some magic that we might think about, we blow it up to the resolution of the screen, and how we wish to present this as a final result. The techniques themselves have come in many flavors over the year, and we can classify them into 3 buckets now. We can talk about spatial resolution, which is essentially a history-free experience. Here are some pixels, make them bigger somehow. Spatial temporal, which brings in history. How are these things moving in my scene, and where are they situated? Now make it bigger. And amazingly, as we've seen in high-end experiences on PC, on console, ML is finding its way in, as it has in so many problem spaces, work in a way that intuitively we can infer what these graphics should look like. Now, we won't be talking about ML here in this presentation, but stay tuned, watch the space. One day we will. We'll concentrate on spatial temporal. We need to make sure that when we're offering these solutions, they appear at quality, but also appear within the budgets that we're talking about. So can you render in time? Are you sapping your battery dry? What's the overall performance characteristics? And this is where we talk a little bit about the history of the technique that we're offering, Arm Accuracy Super Resolution, or Arm ASR. And we're building upon work that was offered open source by our colleagues at AMD in Fidelity FX. So FSR2 is a spatial temporal upscaler. And we've seen it in quite a few games that have shipped over these last few years. It's robust, it offers a high quality set of results. And beyond that, because the game development community regards it as a mature technology, we thought this was going to be a great place to start. If you already know the APIs, we're asking you to go on a familiar journey on some different hardware. And that makes sense. But what about FSR2 in and of itself? The graphs that you'll see on these slides speak volumes. When you're rendering for games, many of us will be targeting, say, 60 frames a second. So you've got 16, 17 milliseconds to get everything done. And using, as you'll see on this graph, you've blown your budget immediately. This is taking too long for the mobile phones that we'd be looking at during our work. Similarly, the bandwidth traffic is high. And that's an absolute killer when it comes to latency, when it comes to power consumption especially. Beyond that, you've got the compute task. So many of us love writing compute jobs on GPU. It's fun, it's simple, and when you're targeting the high end, you are blessed with resources. You're more constrained on mobile, and we have to be very, very careful around that. If we're overutilizing registers, if we're having to spill, that's expensive bandwidth traffic, and it's also a performance killer. And so when we look at how we might possibly deliver this into the mobile space, the solution must address each of those issues. And this is where we came in. And when I say we, a very, very broad team around Arm worked on this, including some very talented researchers I'm proud to call colleagues. We liked FSR2. We liked the various features that are built into it, but we needed to make sure that we were both delivering a solution that was performant and left users with the right degree of control for their various goals in the mobile space. So, image quality, great. We already know that using FSR2 as a benchmark or as our guiding light, we'll get there. It's proven. We all want to offer high frame rates. That's our goal. We need to optimize. We want smooth presentation. So in other words, we have to be consistent frame to frame and allow for the various sorts of artifacts or features within normal rendering context that may spoil your results. Address the bandwidth concerns. Compute as much as you need and no more. Traffic across your bus as much as you need and no more. And that, of course, leads to less overhead on your GPU, which you may choose to play with in various ways, I should mention. If you have reduced your GPU utilization, you can choose to bank those savings and say, great, we're saving power, we're saving cycles. Or you may choose to fill up that extra GPU time with something else. But beyond all of this, we have to be very, very realistic and understand what developers are trying to do. And as a former mobile game developer myself, I know that device reach is key. It would not really be fitting or helpful, as it could be, if we focus on a narrow range of devices. We can't take a proprietorial attitude. That's not the way to help. So what we wanted to do is make sure that when we offer the solution, it was right there with the developer, trying to follow their needs so they understand that they're going to get all of those users that they really want, people that they want to appeal to, the users that help them move their business forward, and them to succeed on the thing that they want to do, which is make a game. So, we offer you Arm ASR. We are going to claim proudly that this is a best-in-class solution. You know, we've done the sums, we've done the analysis. We know what we're doing with the GPU utilization, memory bandwidth, power draw. And this isn't just a bold claim, it's a verifiable one. It's available to you and has been since GDC via the Fab Store, via our GitHub. And we want to make sure that you can get your hands on it, try it out, provide us feedback if you care to. We'd love that. But more importantly, if it's a fit for you, use it in your game. That would be fantastic. You know, whether you're shipping on Android, whether you're shipping on other ARM-based platforms, we love that. And if you find yourself shipping onto other places too, great. Shared success. We're platform agnostic. But we ought to be supportive as well. This isn't just a dash and grab from our point of view. We have this continued mission with our team to keep offering of our best to support game developers. And that includes both the easy integration steps, but also the tutorials to make sure that you can see how we imagine using it and help us move along together when we think about our future roadmap. So let's take a high-level look at the way in which we might render a frame. Highly schematic, but I think it helps in making choices about what fits and what does not. So imagine that you're rendering a scene, and it's got all of its wonderful actors, geometry, terrain, all of that stuff. And this is the first part of the graph on the top. Scene actors in place, frames rendered. Apply some anti-aliasing. and then whichever post-processing that you need for screen-based effects, any UI overlay. Very broad strokes, but this is the typical things you would see in a graphical frame. Good. So what if we wanted to make a change to that and introduce upscaling? Well, we're going to profile that as well. First of all, you can get the best possible case where upscaling is free, which of course it is not. So you can profile at lower resolution, look at what the lower bound is, that is to say the fastest possible rendering time with no adjustments. And then we can look at introducing upscaling into the frame. And then it comes down to a very cold-blooded decision you can make about whether it hits your own goals. In this case, we've expressed this in terms of time. Does it fit within your time budget? Does it net out positive? Something that you might equally well do is take your horizontal axis and say, well, here is my power budget. This is what I'm spending on this, that, the other thing. Does that give me ROI? So, a little bit of evidence. I won't name the phones, but they're popular, they're well known, well used. And we integrated into Unreal Engine, and we tried this with both the mobile renderer and the SM5 renderer, playing with our quality presets to see where we went. And what I'll say is that for the workloads that we looked at, and when I say we, actually, I should pause for a moment to acknowledge the work that Enduring Games did employing Arm ASR, because they actually provided us with this analysis. Much appreciated. They showed us it. We see the figures. We can see how it can fit within a rendering frame's budget. And that helps everybody, I think, understand a little bit about where they can invest techniques like this. As a word of caution, though, remember that we are reducing workload, at least within the fragment portion of the frame. And a tactic that your handsets might adopt is to underclock your GPU as a result. I'm doing less work, therefore I'll run slower. And you may find yourself back at step one. So always profile, always try and understand what's happening within any particular frame. We also put it to the test in other stretching ways. So our content team at Arm produced what I'll call a fairly sophisticated scene with an Unreal Engine in which we enabled Lumen and gave it a very strenuous lighting test. And what we can see is that the difference between using Arm ASR and turning it off was night and day, no pun intended, in which we can show that it does make this a viable choice to create SM5 loaded scenes with Lumen enabled at a frame rate that makes sense. More analysis, and in many ways, for me, this is a blast from the past, because this scene that was made from Lumberyard's Bistro, open source content, was where we began analyzing the benefits of Arm ASR. So you can see the full screen, scene rather, that's rendered in large, and then a zoomed in portion. So take a look at that, look for key aspects of the enlarged portion of the scene, and watch for details around the bike, look at the chair struts, look at the clarity of the text. What you can see there, I hope, is fairly convincing evidence that the quality is in place, is available to you if you choose to employ this particular tool. Once again, I'll remind you, don't take my word for it. It's on the Fab Store, it's on GitHub. So with all of that said, I want to take a pause and move us on to the next portion of this talk, which will be conducted by Pete Sauerbrei, where he's going to show you even more of the proof of the pudding. What can you do within high-end titles to achieve even better results, uplift the player experience further? So thank you.
Thank you, Peter. I'm Pete Sauerbrei. I'm the lead of our Tech Mobile group at Fortnite. I'm here to kind of give you a real-world example of applying Arm ASR to an actual game. Clearly, the game will be Fortnite. So why would we look at Arm ASR? Well, in our case, we were tasked last year, sort of the beginning of this year, to improve the battery life, the thermal levels, and the performance of Fortnite on mobile devices, with the trying to hit a better, smoother frame rate at 60 hertz for the game. And so what we're going to go through today is sort of how we integrated it and what the results are that we're seeing. But let's first start with an actual video showing the actual integration. So what you can see here is on the left is Arm ASR on, and on the right is it off. You'll notice probably one of the biggest initial benefits is that it will smooth out some of that anti-alias or that aliasing that you see in the distance. There's also a variety of other features that are turned on the left that are not quite as obvious in this scene as we will show later, but this gives you sort of an example of what we're seeing right now with this. And I will point out that this is all running at 60 frames per second, both sides, but with a little bit better look on the one side versus the other. So let's talk about what's going on here with why we're looking at this a bit more closely. So Fortnite back in 2017 or 2018 when we first brought it to mobile was sort of a best-in-class sort of game with running at 30 hertz at the time because it was lower resolution or lower performance devices. But as the devices have gotten more powerful, we've been trying to get it more and more up into 60 hertz. And so these days, as players on mobile are kind of looking for their game, they're looking for smooth gameplay at high frame rates that stays smooth throughout the match, as well as low thermals and allows them to play their game for quite a while. I mean, if it only plays for 15 minutes and your battery's dead, well, that's not very helpful for you. You want to be able to play for a decent portion of your day. So for games like Fortnite, which kind of push the CPU and the GPU on mobile, that's where ASR potentially can come in, and we'll show more of that here in a little bit. It enables us to reduce that load, and then from that either provide that to the player for longer play times, or provide that as a greater visual fidelity. So let's take a look at how we started to integrate it. So this partnership started back after after Unreal Fest Seattle, when Arm talked to us about whether or not we would be interested in some technology that they were working on. And so through the course of that, we took that particular GitHub implementation and added it to Fortnite so that we could actually see how it might work. Took us about a week or two to get it working initially. And initially we started without without the reactive mask turned on. So why is that important? Well, for us initially we were seeing ghosts, sort of a ghosting sort of thing on our playback. So if you see here sort of the inset, sort of the feathers that are on the spear there, they kind of have a sort of a blurred out look. And when this is in motion, you can see that kind of, the motion blur kind of trail behind in a ghosting sort of manner. And so we talked with Arm a bit and they said, well, let's try turning on the reactive mask. So we did actually that. And here's an example of what the reactive mask would look in this case. The reactive mask itself kind of takes the reactive components, roughness, specular, translucency, and adds that in with the temporal components, velocity and depth data, to generate this sort of mask you're seeing here to help us figure out exactly what should be upscaled and what should be smoothed out and what's missing and that sort of stuff. So with that, we then get an upscale that's much more crisp and much with no ghosting whatsoever, which helped provide a better, more clean look for Fortnite as well. So let's go a little bit more over some of what our code changes were. We did have to make some slight modifications to the engine and to the plugin to make this work for Fortnite. One of those things is that we updated the API for Unreal Engine, the mobile renderer portion, to be able to provide the inputs that the ASR plugin needed. So things like the velocity buffers and motion blur buffers and those sorts of things, and the color and depth. We also added we also updated our post-process commands to be able to call it properly on the engine side. And then there are some other minor changes that we made, such as using either the mobile scene textures or the deferred scene textures, depending on which one is available, depending on how you've enabled the texturing and the shading in the mobile renderer. These changes made it possible for ASR to work with our optimized version of the mobile pipeline for Fortnite without really adding any significant overhead on the CPU side. The API changes that we have made on the engine side are in Unreal Engine 5.6, so they are available. The portions that we made to utilize that engine in the plugin itself have not made it back yet into the GitHub. We are working on packaging that up and getting it back into there so that everybody can benefit from that. All right, so Peter had mentioned that ASR really helps when you're on the pixel shading side of this stuff. One thing that we see sometimes in Fortnite is that we are vertex bound. So to help us make ASR more beneficial to us, we've been optimizing our content. One of those optimizations that we have here is a landscape optimization. So what I'm showing here is on the left, there is our default landscape that we've been using for Fortnite in the past. High density meshes. Looks brighter on the left because we're using a brighter color for the wireframe, and it's just that dense that it's brightening up the entire image on that side. And you can see that there's actually an LOD further in the distance on that side, which still shows pretty dense polygonal counts for the landscape itself. On the right is our new optimized version of this, where we have coalesced coplanar polygons to reduce the amount of vertices that we're trying to push through the pipe. And that actually helps reduce the overall vertex boundness of our game. We're still vertex bound in a few places, but for the most part, this gets us mostly to fragment bound, which allows greater benefit from ASR. So with that all in place, we've now integrated, we've now optimized a bit more to help ASR, to allow ASR to help us more. What do we see from a performance standpoint? Well, here's our initial graphs. So I'm going to go back to something Peter said, which is profile. Make sure you profile. Because sometimes you'll see something like this, where you're like, QA comes back to you and says, hey, it feels cooler, battery's a little bit better, but when you get GPU times, 30 frames per second is showing a higher GPU time than with ASR than without. And about the same at 60 frames per second. Confused us for a bit, because there was a difference between what people were feeling with the devices and what we were seeing from performance. So we dug a little deeper with the Arm profiler to get clock speeds. So the GPU clock speeds had dropped with ASR on to sort of bolster what Peter was saying before, which is less load. So the load balancing on the GPUs and on the CPUs reduced the clock speed, which actually made a lot of sense then with our experience from what QA is telling us with a little less heat, a little longer battery life. So don't necessarily take one number and choose to make that your, oh my God, it worked or it didn't work, because that doesn't necessarily it's not always the right call here, because we definitely saw this. Now, I forgot to mention that this was an S24 running at 60 frames per second and 30 frames per second with ASR on and no ASR on. Now, to be clear there, no extra features were enabled. This was just turning it on and off with default Fortnite. And the reason why I'm going to sort of kind of bringing that up is because, well, that meant that we now had more GPU time and more GPU load where we could potentially add more features in. So that takes us to, what did we add to this? So now we had something that we knew was going to help us with potentially thermals and battery life, but we wanted to see if we could take this thing and make it, really, really add some more visual fidelity as well. So this first screen here is just Fortnite, the way we normally send it out of the box. No ASR, a screen res of about 75% on these dense pixel devices. And you can see it's a little meh, I'm sorry to say. It's got a lot of jaggies in there. The distance looks a little light, and shadow's not in a lot of places. The foliage up close looks pretty nice, but it doesn't go very far. There's not a lot of screen effects on for this particular run. But as we see here as we go, so first we did is just turned Arm ASR on, kept the same screen resolution. And you'll already notice right away that it sort of cleaned up some of that jagginess, which is sort of the whole, hey, it can do TAA while it's added effect with this. But also, makes the game just look a little bit better over what we were seeing before. So that already is reducing some of our GPU load, but we figured let's try going a little bit lower. Now I went backwards, sorry. There we go. Now we're going to a screen of 59% res, and you can notice that it doesn't really change over the 75% res, which is what we were hoping would be the case, giving us yet more GPU time to work with. I'll also point out that I've forgotten here that we were using the performance shader characteristic. There is a quality and a balanced version as well, which we do want to spend more time and actually play around with, because I do think that'll improve the visuals even more. So with the screen 59% and Arm ASR on, GPU load is down a bit. Let's see what we can turn on. So the first thing we enabled was more shadow cascades. And you can already see that there is a bit of more shadows down here. The distance actually got a little bit more shaded, darkened as well from the distance shadows that we turn on from that. And then from there, we turned on foliage density. Now, this mostly just changes the density in the front. You don't see any extra in the distance, but it is a bit denser, a bit more PC style on the foliage at this point. So now we're getting the densities of PC, we're getting sort of the shadows of console, maybe a little bit further into PC as well. And then, well, we just kind of turned everything on at once. And so now we kind of have a larger distance with distance culling. We've turned on a variety of post effects, including screen space reflections, ambient occlusion, some tone mapping, and quite frankly, now we have foliage going down the hill all the way down into the lake here. We've got a lot more visual fidelity in the scene in the back, or the city in the back, as we've now been able to render that data as well without having to distance cull it. So overall, a more visual rich screen to look at. So just to recap, before, after. And we'll kind of do it one more time, before and after. And so we've definitely improved the look. We've added the ability for users to see further, see more further. And it's also still all running at 60 frames per second. None of this has reduced the frame rate. In fact, Arm ASR has actually reduced our missed vertical sync to a third of what it was before, from about 24% down to about 8% at 60 frames per second. So clearly, we're seeing quite some benefit from Arm ASR being enabled in Fortnite itself. All right, so where are we going to go to next with this? So with this now enabled, that sort of leads us down the direction of some other possibilities for us for Fortnite. Enabling SM5 is one of the things we've been talking about even before this, but now this really becomes more of a feature that we want to go after. And that then enables the ability for us to start to bring more and more desktop features to Fortnite and the mobile platform, and make the artist's vision more similar across all the platforms that we support. The nice part about this is that what we have shown here will ship soon on Fortnite. In fact, it will ship in our release that is upcoming on select Android devices. And then a lot of the extra features that we've enabled will soon follow thereafter as we get a bit better testing across more of our devices. So I'm expecting the visuals of Fortnite to actually increase dramatically in the next 2 to 3 months. So that's a quick look at how Arm ASR is helping us push Fortnite further on mobile than ever before. But before I wrap up, I want to give a special thanks to the engineers who made this integration possible. Our rendering engineer, Brad Blankenship, did most of the integration work and found various optimizations that would help our rendering engine work well with the plugin. And then our optimization engineer, Dennis Cementiai, worked with Bruno Ferreira to do that landscape optimization that we just shown. Their efforts were essential in getting ASR running in Fortnite, and so I thank their efforts. It's been a fantastic collaboration with Arm, and we're very excited about what this unlocks, both now and down the road, and thanks with all that. I'll give it back to Peter.
Thanks so much.
Yeah.
This is the stuff that really makes my heart glad. We're talking about immediate results that benefited, in this case, the Fortnite team to crisp up their scenes, to offer elevated user experience, and it speaks to the road ahead. Pete mentioned the SM5 renderer. And so, in a way, we're playing a small part in making the future happen faster. And that is exactly where I love being, and where it pays off in tangible results into the Unreal Engine. Well, isn't that a wonderful, wonderful outcome? And I would also add that, of course, they gave us product feedback. We helped web going to become better as a result of the feedback that they're going to give us upstream into our GitHub, and everyone can benefit from that. Excellent. So in these closing slides, what I'll do is I'll talk a little bit about how you can start taking benefit from Arm ASR yourselves, some hints on working practices, and then finally turn over the baton to you if you choose to pick it up. As mentioned, we got 3 presets, and you can choose to go immediately for the high quality end, where you were really working hard to maintain image quality. You can go for the middle of the roads, which we believe is quite a good compromise between image quality and resource demand. Or you can lean into performance, where we will make some trade-offs on image quality, but you'll get further benefits in terms of power draw and time saved on your GPU. These are all for you. We don't feel it's our place in this world to steer you towards any particular choice for your shipping decisions. But of course, you've got to start somewhere. So we suggest you start in the middle, see what you get out of it, and then adjust to suit. It's yours. As mentioned, this solution is platform agnostic. We want to make sure that you're getting as much benefit in your games as is humanly possible, that it's realistic for you to adopt. And so this feels productive for everybody. And so although we're proud to support officially Vulkan and Glez, you'll also find that it works very well under DX1112. And we know from other people who are using this, it runs just fine on Metal and other closed platforms. We recommend that you think about whether this is for you or you don't. ASR is not a silver bullet. It's great when you've got expensive pixels. And it's great when you have the performance there already within your device, which is so significantly, or devices that are modern enough for this particular tool and technology. So in other words, we're saying devices that come from, say, about 2022 onwards, these should be a pretty good fit. But you still have the rest of your audience to cater for, and you may find that you still want to use upscaling. And at that point, you may choose to use a cheaper spatial upscaler in order to hit your goals. Adjust to taste. And as mentioned earlier on in my first segment, we want to be here with you. We want to hear from you. We want to make sure that we're continuing to offer you genuinely useful tools, whether that's through Arm ASR, and you can find the links on the screen right now, or if you choose to engage with our performance tools, as Pete mentioned earlier, please get your hands on those, learn a little bit more about how to optimize your frames, help us learn how to serve you better. It's all there. Come visit us on our developer sites, because it's something that we're very proud to do, to see these practical outcomes where games ship, people take pleasure in playing the games, and we can feel that in some way we helped you deliver. And that takes me to the final slide, where I warn you I'm likely to gush, because thank you is too short a phrase. In order to get to this point here on the stage, we relied on so many people and the great work that they did. Whether we're talking about the foundations, which is, of course, with FSR2 and AMD, we're greatly appreciative that they took the stance they did and offered this technology to the world. Within my own team, this covers the fundamental optimization work that happened within our graphics teams, the proof of the pudding that came from our content team, the productization work that came from our XPK team, all the supporting mechanisms around it through developer education, through our legal team to get clearance for open source. So many people, alongside the partners that have chosen to engage, whether that happens to be Unreal Engine and especially Fortnite, or others such as Enduring Games and others around the world. It's been a wonderful journey. Let's keep it going, because it's the stuff that we really live for, and I hope that we're genuinely offering you that help. So thanks.